everyone for showing up. Today we'll be talking about prototyping with R packages. Margot already gave a great intro, so I won't go too much into detail here. Today we'll be dividing it up kind of like this. I'll be giving the theoretical overview of kind of our workflows, and then Yogev will be talking about the fraud case study and kind of focusing on like a concrete example to kind of understand what we're talking about when we're talking about these processes. Riskified started out focusing on verifying orders at checkout for online merchants. And so what Riskified did was it checked to see when you go online to buy some item, so a pair of shoes, the moment you press buy or purchase or whatever that button says, we have a few seconds to decide if the details you've entered matches the cardholder's details. Like, we want to make sure the person who has the credit card approves this purchase. And so if we see too many mismatches, we'll probably decline the order. And so we are the ones making these decisions for merchants and then taking liability if we get the answer wrong. And so since the beginning, or since the initial product, we've kind of expanded to different parts of the shopping process, trying to catch fraud at login, also dealing with what happens after you make a purchase, like returns, if you don't receive an item, trying to kind of find fraud in those different steps of the process. And just our team is the one in charge of the machine learning models that goes behind this whole process. We're the ones picking out data sets, training them, creating new features, thinking of other types of models that we might be able to incorporate in order to make a better decision. And we work closely also with analysts to make sure like our models are doing a good job and have some kind of feedback loop. And so today we'll be talking kind of about like the process of moving from research into production. And I really, really like this slide from Heather and Jacqueline Nolis in their presentation about a year and a half ago at RStudio Conf. They put it this way: you have kind of analysis mode, and this is where you're running code once to produce some kind of result. And then you have a build mode, which is you're writing code that is continuously running, and that's kind of what we mean by production. At Riskified, we kind of put it in terms of departments. We have the research department, and most of the time we're writing code that answers questions, delivers some kind of idea. And then we have like the developers. We have a team of over 100 developers, and they're writing code that takes some kind of input and is able to consistently produce an output. And so today we'll be really focusing on that transition because, an idea can't magically become developed code without some work, and how we start from. And so kind of going through the steps of starting from exploratory analyses, eventually starting to package code to prepare it for handoff, and then deployment, which is often in collaboration with the development team. And so we're going to start off with exploratory analyses, and I'm sure this is a step that most of you are familiar with. We love using scripts to start out. When we're starting out on a brand new project, we are really aiming for things to be fast and to be flexible. Typically, sometimes it starts out even half interactive, but eventually we want a script that is somewhat organized. Usually we start by loading some packages, having then functions and constants that we're using, and then we have the data ingest, which is getting things from a CSV, the database, whatever, and then all the wrangling, plotting, stats, whatever after that. Of course, most projects don't stay this way for very long. The next step is usually like a whole suite of scripts. You have a functions file that contains the functions, often the libraries. This is what runs first and sets up our environment for us. And then we have our other scripts, which we try to keep numbered, try to keep organized. And if we have tasks that we do fairly frequently, for example, model training, we try to make sure that there's like some kind of regular pattern that everyone is following, so it's very easy to open a project and really understand what's going on. And so this is an example of what that might look like. Here we have In our project, everything we do is pretty much in an R project, so that things are well contained. We then have queries, SQL queries or data that we're using for the specific project. The scripts and function files that we talked about, and possibly most importantly, we have also a research report at the end. And this is particularly useful for presenting our findings to stakeholders, product managers, our team managers, other people who are interested in what we found in our analyses. So Yogev will take it from here.
Okay, so hello, like Irene said, I'm Yogev. I'm going to try and give a concrete example of what Irene says, showing some case study of one task we took in Riskified from the analysis period until to the production. And this case study is the case study of what we call BOPS fraud. BOPS is an acronym we use, which just says buy online, pick up in store. It's a shipping method offered by many of our merchants. What it simply means that when you buy something online, instead of waiting for the delivery to come to your house, you go there by yourself and pick it up from the store. Customers like it. I personally like it because it's fast, it's flexible, it's frictionless. So we as Riskified also support orders that use this flow. But as you will see, that this kind of flow and order has its own unique challenges when it comes to detecting and stopping fraud. And before we dive into the R code and exactly how we did the project, we're going to explain a bit how fraud works in this domain of BOPS. Now, so what's going on here? As Irene said, remember, our job as Riskified is whenever an order takes place, we need to review the order very quickly. Our machine learning models do so, and decide whether it's the cardholder performing the order or some fraudster who got the cardholder details is performing the orders. So how would a legitimate, non-interesting order look in BOPS? Let's say we have some generic guy with a credit card. He has luckily also a very generic name called John Smith. And he enjoys dancing. So he wants to go online, buy his dancing shoes online, and he goes into the dancing company's website, puts in his details, writes in the card details, which means his name, his address, and his credit card number. But he wouldn't be downtown, so he wants to ask his partner to pick up the shoes for him. So in the name of the shipping name, whoever picks up the product, he writes the name of his partner, Jane Smith, and she will go downtown and pick up the shoes for him. What will happen at the store? That the store will look at the order, will look at her ID, make sure that the name and her ID matches the order, and will give her the product. That's how a very regular, uninteresting order looks like. Now let's look at a fraudulent case. Let's say we have the same John Smith, but this time someone manages to steal his credit card details. This guy has the very unsuspicious name of Fraudy, Fraudy the fraudster. So Fraudy the fraudster wants to steal sunglasses using John Smith's credit card details. So when he makes the order online, he will put all the billing details of the same John Smith, his name, his address, his credit card number, but in the shipping name, he will put the fraudster's name, his own name, Fraudy. And then when Fraudy the fraudster will go up to the store will see that his name matched the name on the order, matches the ID of Fraudy's, and he will get a product he just bought using someone else's credit card. That's how a fraud in BOPS looked like. Okay, the important thing to remember here is that the fraudster needs to use his real name. Because if he wouldn't use his real name, he won't be able to pick up the product he purchased with a stolen credit card. So this is, and another thing to note here is that if a fraudster performs the fraud well and high quality, the only data point that distinguishes between a legitimate order and the fraudulent order is the shipping name. all other things in the order can look very similar. The only thing that will be different for sure is the name of the fraudster on the order. So let's say Fraudy McFraudface managed to do this fraudulent transaction. We at Riskified aren't stupid, and next time he tries to perform to buy something with a stolen credit card, we will see that this name has been linked to fraud, and we will decline orders made by him. But also Fraudy McFraudface wasn't born yesterday, like they say, apparently, not only in Hebrew, also in English. And he knows, and he managed to figure out that if he changes the way he spells his name a bit, it can sometimes fool our system, okay? If he adds a few unnecessary letters, he invents a middle name for himself. If it's far enough away from his original name, our system might not recognize that it's the same identity. And he'll be able to go and pick it up because it's still close enough for the human who reads the name and the pickup to get the product. So this discrepancy between the name that a human reads and the name a computer reads is a loophole that fraudsters managed to exploit in our system. About like a year ago, we started getting reports from merchants and from analysts reviewing orders that they see more and more orders with the same name, with the same identity behind them, but spell a bit different. Some of them were successful attempts of committing fraudulent orders. And we at the data science team got the task of trying to understand what's going on. First of all, whether or not it was a big problem like it seemed for the people reviewing orders. And second, and more important, to find a way to close this loophole in the checkout process. Okay. So quite early on, when we got the task, we understood that what we need to do is find some method to reliably take all the shipping names we have in a merchant in our system and classify them into discrete identities. Find some way to say that these five names, even though they spell different, belong to one identity. These other names belong to another identity. And once we match them to identity, we can flag the identities that are fraudulent and decline them to commit fraud. And luckily for us, now we're getting to the R part finally. Whenever you have one of the nice things that I specifically enjoy about R is that whenever you have almost every time I had a problem which is new to me, I didn't know where to start. I didn't even know how to Google it or something. I found out that somebody somewhere in the world already solved this problem with a package he or she built. And most of the answers I'm looking for is already in this package. In this case, our problem was that we needed to find a way to understand how far names are from each other or strings are from each other. And we quite early on ran into a nice package called stringdist, which, as the name suggests, implements a lot of different algorithms to compute distances between strings. Given two strings, it tells me the difference between them. If anyone has like a bioinformatic background, Levenshtein distance is like the classic algorithm or something, but that's the idea. Once we had this package of computing distances between strings, we could quite easily create a distance matrix between all strings. That is, given a vector of strings, computes the distance between any two strings in the vector. And once we had a vector, a distance matrix, we can easily, I think if someone did it, you can raise up your hand and say, build a tree. Because once you have the matrix, very easily you can build a tree with an hierarchical clustering algorithm. And once we had a tree, we can cut it at a certain length, and anything right of the cut is considered its own unique identity. And that was quite a simple implementation. We found a way to turn a vector of names into different cluster of unique identities. The exact solution was a bit more complicated than that, but generally it was something using distance between strings and hierarchical clustering. We got, and after we validated it and tested it, we found a good algorithm that reliably clusters name and to identities. And once we had that, that was the end of the research task, of the exploratory analysis, as Irene said. What did we have by the end of this task, of this exploratory analysis? We had, as we said, the method for reliably clustering names. What you see here in this table is the validation of different algorithms we use to see which one works best on the data we have. We had some measurement of how severe the problem was, some concrete measurement. We found out that, for example, about a third of the successful fraud performed in BOPs belonged to a few fraudsters using this name-changing method of operations they had, which was quite severe. If we manage to close down this loophole, we can save a third of the fraud, which is substantial. And we had also from this research some analytical insights about how this fraud works. For example, one thing we learned from this exploratory task is that fraudsters who perform BOPs fraud usually perform most of the fraud in the same geographical area, which kind of makes sense when you think about it. Nobody will drive 5 hours just to steal a bottle of perfume. In this map, you see here one fraudster which performed a lot of different fraud. You can see it was very active. Every dot is a store where he stole a product from using someone else's credit card. You can see that he was very active in the New York, New Jersey area, except for one time he had some business in Baltimore and he went and committed fraud there. But generally, each identity was unique to one certain geography. And this is where we ended up our research task. Now I hand over to Irene.
Oops. All right, so now that Yogev had some conclusions, we decided that this was a good research direction. We wanted to move forward with it. And now maybe not just Yogev is gonna work on it, but also someone else in the team. And so this is where we get to the step of packaging up the code. So when we're talking about scripts, we really like that it's flexible, but it does come with a few disadvantages. A lot of the times your documentation, you might have some in the report, you might have some comments like nestled in your code. Your dependencies, there's no real good way of checking your dependencies. Like you might have library calls spread throughout your different scripts. It's like maybe you forget one and you don't realize until you actually run through all your scripts. And for example, once I start working on this project, often what happens is that we're copy and pasting code. Maybe like I try to connect to his code with some file path and it gets messy. Maybe we actually want to be fancy and try to use a branch, but often, if we're both working on the same task at once, it also gets messy. And then often what happens is we just have code that's unmaintained or several versions of the code. And so this is where the package comes in. If you just want like a very basic package, just like the bare minimum, it's actually very easy to get started. You have dev tools, use this and other packages that get you up and running very quickly. But then you start to have to invest in the infrastructure. And so basically you're moving away from really focusing on the analysis, and you're now starting to focus a little bit more on the infrastructure, on adding documentation that other people can read, keeping your dependencies organized and your functions organized. It becomes a lot easier to implement some kind of testing infrastructure, and it maybe becomes worthwhile to start testing your code more rigorously. And the biggest thing for us is that it's installable. Like if you're working on a public project, you can just put it on GitHub and now anyone can install it. For us, the work that we do is a little bit more proprietary, but we have a Riskified CRAN that we all have access to. And once we put it on our Riskified CRAN, anyone in the company can just install it and start to use those functions right away without having to find which GitHub repo it's in, exactly how to install it from GitHub and all of that stuff.
Okay. So let's return to the narrative of our BOPs project. So when we left on, we finished our research project. And we wanted to turn the insights we found in our research project into actions to work in production. That is, instead of having a script that researches what happened in the past, have a script that changes our decisions in real time. So one way we could just tell the dev people, here's our solution, please implement it, but that could take time and would be long. We got pretty much to the conclusion that if we already had the code for implementing the solution in a research task, let's try and make it work in production. Let's have the algorithm we developed in a research task, write the names of suspicious identities to our database, and these identities will be flagged and wouldn't let to be committed fraudulent orders. So we wanted to take the code I wrote and turn it into a package. So that just presented a few challenges. First of all, we needed to understand who will be the one using this package. Okay. When I created my code, I really enjoyed doing all the statistical analysis and looking at the different algorithms and learning and so on. But we understood that the person who will use this code isn't interested in all that. He wants something very simple that will be able to detect fraud quite easily. So we needed to wrap up all of my code into some simple functionality that can detect the fraud quite easily. All the other things that will happen, all the fancy schmancy stuff that I did and I really like, will be under the hood, and they should be invisible for the person using this package. So we needed to define exactly the functionality of the package. Another thing we needed to understand with the package is that even though I myself wrote my code quite easily and I think I understand it and it's simple, other people might find it a bit hard to use this code, and other people can be annoying sometimes. So we need to help them use the code as intended. So first of all, we need to make sure that it's well documented. And again, these things have really nice defaults to use in R. So in this case, documentation, you can easily create a documentation of an R package using Oxygen 2 in our packages. We also need to make sure that when people use the package, they use it the way it's intended to use. And if someone wants to put in a numeric value where I intended it to be a screen, my package will tell him, please put a numeric value there, a string, not a numeric vector. That is, I need to add assertions. I really like the assert that package. If anyone is familiar, I assume people are familiar with it, but there are many other ways to put into an assertions, even with base R, but I find it really helpful and easy to work with. And last thing that we can say that it's annoying about people is that when people use your code, they tend to find bugs. And even though I think my code is perfect and so on, somehow people always find bugs in my code. I don't know how. And that adds another layer of complexity which can be easily performed in packages, that is unit testing. Make sure that when a bug is found, it's fixed. And I know that when it's fixed, it doesn't return to other people. All these things are very, very, very easily implemented almost by default when you create your own package, which helped us a lot. And last challenge of turning my exploratory script into a package was that when I write a script, I usually load the packages and use the functions quite liberally without worrying about namespaces. When I create a package, I need to be much more declarative on which functions I use from which package. I need to use the name with the prefix. So when I started performing this, my original way to solve this was to look for a function using Control F and replacing it one by one. That turned out to be a very stupid way to do so and took a long time. And about midway, I found that there's a great add-in for RStudio called Prefixer that pretty much does this whole process for you without you even needing to work so hard. So if anybody ever has this challenge of turning a script you created into in some other way into a package, I really highly recommend using the prefixes. It can save a lot of time and head bashing into the wall. And once the package was done, we it was code reviewed and people saw it was working. We uploaded it into our own Riskicran, or the Riskiverse, as we liberally call it. That's where all our internal R packages sit. You can see it here. We even have our own hex, Riskified hex, which is thanks to our design team. You can see it's on Irene's shirt. And now it's available for anyone in Riskified to download and use without having to worry about anything. The code is already available there. And now comes the part of wanting to deploy the package. So in this case, when we move from analysis mode to production, the difference when we say the code works in production, we say that now the code has some real influence on the way our system works. Instead of it being run only in my computer, now it affects the decisions we make in real time. So every time you put something in production, it's scary because there are so many things you can break on the way. I wouldn't want people to get declined for no reason because of my code. I want to make sure that when I write the code, it doesn't break anything. So the first thing we did was just I ran the code locally on my computer, made sure it ran to the DB and saw its effects, small scale. You see that nothing breaks, that it works, that it does what it's intended. And I did this for a few days. Every time I got in the morning to the office, I drank my coffee, ran the script, and see that everything is okay. After a while, when we felt comfortable, the code does what it's intended to do, and that nothing too serious breaks, we decided to run it automatically every hour or so to detect fraud in real time and make sure that fraudsters can commit more fraud. And here again, there was something really nice about having it packaged in an R package, because already in my R package, I have all the dependencies I need to run this code. So in this case, I needed to bring it to programmers who didn't know anything about R, but they could easily understand what needs to be in the computer that runs the automated job without having to understand anything. You can understand that you need R package from X version, other packages from a different version. It made our life much easier to have it packaged in this way. And that's, before I hand back to Irene, that's our story about how we pretty much took one code we wrote for analysis and got quite a long way with how it could affect our decisions in real time. And now Irene will explain it much better than I did.
All right, so we're getting to the end of this presentation. So basically, as we said, we started with exploratory analyses, where we try to understand the business value. Is this a direction worth pursuing? We start to produce some example outputs. And this is an iterative process, right? Like, we want to understand the data, we want to understand it in different ways and improve on what we learned previously. At some point, we decided, okay, now it's the time we want to package code. This might be to collaborate. This might be to just be able to talk to the developers and have something easy for people to run. And then we start investing more in the infrastructure, documentation, tests, so on and so forth. And then the last step is deployment. And so, like in Yogev's case, he started off with this daily manual process just to make sure things were working, nothing was breaking. It started off offline, not online. It wasn't like making decisions like real time, as orders were coming in, we were doing it in batches. And right now we're not optimizing for speed and scale. That's a question we can handle later on in the process. And this is where we work with our developers. They're able to think about those aspects of the process. And so because we went through this, gradual ramp up in the process, we were able to stick with our R code through a lot of it and just kind of add on different layers on top of it. And so basically, going from the analysis to build mode involves shifting a lot of your mindset. It involves investing in different parts of the code, whether it's analysis or more the infrastructure. And that way we were able to kind of gradually transition from research code that really prioritizes new insights, flexibility, to something ready for development, which prioritizes reuse, stability, and also later on scalability, speed, storage, and all of those things. And so with that, thank you for your time. The baby has joined us, not my baby, Yogev's baby. And our Twitter handles are here also. If you want to contact us, we also have a Riskified technology blog. If you want to read more about, there's a lot of like dev content there as well. If you want to read more about what we do. Thank you.